quadratics. When you're solving your quadratics, the first thing that you want to try to do is something called factoring. Factoring works because we have something called the zero product property. The zero product property says that anything times 0 is equal to 0. So earlier, when we talked about a quadratic equation where we have ax squared plus bx plus c is equal to 0, if we can find any factor of this and set it equal to 0, then we know the whole equation has to go to 0. Things that we can look for when we do factoring are the greatest common factor. For example, if we had x squared minus 3x is equal to 0, I know that I can factor in x out of both of these values. So I have x times x minus 3 is equal to 0. Now I can apply my zero product property such that either x is equal to 0 or x minus 3 is equal to 0. If either one of these statements is true, then this equation is satisfied. Thus, we solve this little mini equation for x by adding 3 to both sides, and we're going to get x is equal to 3. Another way to solve a quadratic is the difference of two squares. Here we have an equation where we have x squared minus 9 is equal to 0. We can factor this as the difference of two squares, and that factors into x plus 3 and x minus 3. Again, we apply the zero product property such that x plus 3 is equal to 0 or x minus 3 is equal to 0. Solving each one of these mini equations yields x is equal to minus 3 or x is equal to 3. Now, if these do not satisfy the conditions of the problem that you're working on, then you want to use some other techniques as well. Let's say that we have the equation where we had x squared minus 6x plus 9 is equal to 0. Here we can use and try to figure out what two factors will make this product. I'm going to try x minus 3 and x minus 3. I can check by foiling. I'm going to FOIL my first is x times x, that's going to be x squared. My outers are x times minus 3, that's minus 3x. My inners are minus 3x. And negative 3 times negative 3 is positive 9. That gives me x squared plus 6x plus 9 is equal to 0. Sorry, negative here. So I know it works. So I have my two factors here, which I can now solve using my zero product property. X minus 3 is equal to 0 or x minus 3 is equal to 0. We recognize it's the same thing both times, so therefore the answer for this is going to be x is equal to 3. Another type is something like x squared plus 5x plus 4 is equal to 0. Here I'm going to try to factor this using our double distributive property. I'm going to try x plus 4 and x plus 1. Here, x times x gives me x squared. That's great. Now again, I'm foiling here. My outers are going to be x times 1. That's going to be plus x. My inners are going to be 4 times x, which is, well, 4x. And then my last is going to be 4 times 1, which is going to be equal to 4. Combining my inners and outers together, I'm going to get x squared plus 5x plus 4 is equal to 0. So therefore, I know that I factored it properly. Now I can use my zero product property. So I have x plus 4 is equal to 0, where x is equal to minus 4 if I solve for that. Or I have x plus 1 is equal to 0. Subtracting 1 from both sides, I get x is equal to minus 1. Now, if these techniques don't work and they're not available to you immediately, there are 2 other things that you can do when you're solving quadratics. You can complete the square, or you can use the quadratic formula. The quadratic formula works in all cases, and I'll put that as a separate video as well. The complete the square will work in most cases, although it's a little bit more complicated. It's a great technique to have later on when you're looking to find vertices of parabolas.